Hello students, now we'll continue the problems on permutation and combination. So if you have watched the previous video, you have understood the meaning of the term permutation and combination. I have explained in detail the concept of permutation and combination, what are the different types of permutations, and we have solved 8 problems in the previous video. Now we are going to start the next problem, that is problem number 9. So hope you have taken the printout of the problems. Before watching the video, I suggest you to take the printout of all the problems from the link in my description. So go to the description, in the last line you will find the link, click the link, get a copy, hard copy of the problems, then you start watching the problems. Then only you can be able to understand. Now see the 9th problem. I am reading out the 9th problem. Find the number of ways in which 5 managers can be seated on a round table. Up to 8 problems we have seen linear permutation. Linear permutation means arranging all the objects in a straight line. Now there is another type of permutation called circular permutation, where objects are to be arranged in a circle. The formula will be different. To find the number of ways in which we can arrange the objects in circle is n minus 1. n minus 1. So here it is given, find the number of ways in which 5 managers can be seated on a round table. Round table. So n minus 1, why we take n minus 1? Because first any seat can be the first seat. The first seat can be any seat. For example, a person, Mr. A has been selected and given 1 seat. That is the first seat. Now remaining seats, there is a choice. So for 1 seat, there is no choice. After allotting the 1 seat, there is a choice in the 4. So how to calculate the number of ways in which 5 persons can be seated on a round table? So n minus 1. See, since it is a round table, the number of ways in which the managers can be seated is n minus 1 factorial. So n is 5. So 5 minus 1. 5 minus 1 is 4. So 4 factorial is 4 into 3 into 2 into 1. So multiply 4 3s are 12, 12 2s are 24. So 24 ways. So if 5 managers are there on a round table, we can arrange in 24 different methods of making the arrangement of 5 managers on a round table. तो यही पॉइंट याद रखना है कि लीनियर परमुटेशन में और सर्कुलर परमुटेशन में फार्मूला विल बी डिफरेंट. इन लीनियर परमुटेशन वी हैव सीन NPR. In circular permutation we will have n minus 1 factorial. That's it. Now see the 10th problem. Find the number of ways in which 4 boys and 6 girls can be seated in a circle for playing a game. Again, we want to arrange the boys and girls in a circle to play a game. So how many boys and how many girls are there? 4 boys and 6 girls. So totally 10 students are there. 10 persons are there. So we have to arrange in a circle 10 persons. So again, we apply the same formula n minus 1. 10 minus 1. So 9 factorial. All the 10 students have to be seated in a circular fashion. Thus the number of arrangements will be 10 minus 1, 9 factorial. 9 factorial का मतलब होता है 9 into 8 into 7, 6, 5, 4, 3, 2, 1, up to 1. So if you multiply all, you will get 3,62,880 ways we can be able to arrange the 10 persons in a circle. Next problem, 11th one. Find number of ways in which 4 boys and 6 girls can be seated. 11th problem. In how many ways can alphabets contained in the word choice be arranged if all of them are to be taken together? Now this is a different problem. See here. A word is their choice. How many ways we can be able to arrange the alphabets of the word choice? Alphabet of the word choice. If all of them are taken at a time. Here n is equal to how many alphabets are there? CHOICE 1, 2, 3, 4, 5, 6. So totally 6 alphabets are there in choice. We are taking all 6 alphabets at a time. So how many ways we can be able to arrange 6 alphabets at a time? In how many ways? So we can take NPR. So n is equal to 6, R is equal to 6. So formula will be 6p6, 6p6. So if you take 6p6, it will be 6 factorial only. 6p6 अगर करेंगे तो आपको 6 factorial ही आएगा. How it will be 6 factorial? See here. 6p6 is equal to 6 factorial divided by 6 minus 6 is 0 factorial, and 0 factorial is nothing but 1. So 6 factorial divided by 1 is 6 factorial only. So 6p6 आपको 6 factorial आएगा numerator में. But denominator, here there is a new point. The new point is, in this choice, one alphabet is repeating. One alphabet is repeating, which is the alphabet C. C is coming twice. C is coming twice. So formula will be slightly changed. The formula will be NPR divided by C factorial. C factorial means how many times the alphabet is repeated. How many times the alphabet is repeated. So in our problem, C is repeated twice. So 2 factorial. तो डिनोमिनेटर में ये फॉर्मूला अप्लाई करेंगे, NPR डिवाइडेड बाय C फैक्टोरियल. अगर कोई रिपीटेड अल्फाबेट नहीं रहता तो द फॉर्मूला विल बी NPR ओनली. If there is no repeated alphabet, our formula would have been NPR. But if an alphabet is repeated, then we slightly modify the formula, NPR divided by C factorial. Right? So there are 6 alphabets that can be arranged in 6 factorial ways. However, the alphabet C is appearing twice. Thus, the number of permutations are 6 factorial by 2 factorial. ये new point. ये change करें. अगर कोई alphabet repeat हो रहा तो कितने time repeat हो रहा उसको denominator में लेंगे factorial. तो C is appearing twice. तो C factorial denominator. और numerator में क्या लेंगे? NPR. NPR की 6PR. और 6PR का मतलब 6 factorial. Just now I told you ये 6PR का मतलब 6 factorial ही होता क्योंकि denominator में 6 minus 6 will become 0 factorial and 0 factorial is 1. Right? So 6 factorial by 2 factorial. 6 into 5, 4, 3, 2, 1 divided by 2 into 1, you'll get 360 ways. So these 3 problems are entirely different. These 2 problems are in circular permutation. In circular permutation, the formula is n minus 1 factorial. And here, the new point is one alphabet is repeating. If the alphabet is repeating, denominator will take C factorial. C stands for how many times the alphabet is repeated. 2. That's it. Now come to the 12th problem. How many 4-letter words can be formed from the word jungle? If no alphabet is to be repeated, then will the number be different if alphabets can be repeated in the words? So 2 different questions are there. The first question, how many 4-letter words can be formed from the word jungle? Actually in jungle, how many alphabets are there? 1, 2, 3, 4, 5, 6. In the whole jungle word, we have 6 alphabets. Now we have to make 4 alphabet word. So how many 4 alphabet word we can make? Very simple, 6P4. Number of alphabets in the jungle is 6. 4-letter word can be formed if no repetition is allowed. It can be done in 6P4 ways. So 6P4 का मतलब 6 factorial divided by 6 minus 4, 2 factorial. So 6 factorial by 2 factorial, 6, 5, 4, 3, 2 factorial. 2 factorial get cancelled. So 6 into 5 into 4 into 3, 360 ways. If there is no repetition, then number of ways we can select 4 word out of 6 word, 360 ways. If repetition is allowed, then it can be done in 6 to the power of 4, यानी n to the power of r. एक नया formula है. If repetition is allowed, then number of ways can be found by using the formula n to the power of r. N is 6, r is 4. So 6 to the power of 4 ways, if repetition is allowed. Next, 13th problem. How many 3-letter word can be formed from the alphabets forming the word success? How many 3-letter word can be formed by using the word success? Now, number of alphabets in the success is 7. Right? So, number of letters in a word required is 3. And a total number of alphabets in the word success is 7. And we are going to make a word of 3 alphabets. Letter of 3 words. Now total number of arrangement is 7p3. 7 alphabets है, 7 alphabets है, तो 7p3, तो 7 factorial divided by 7 minus 3 factorial. You will get 7 factorial by 4 factorial, 210 ways. We can be able to arrange 3-letter word out of a total of 7-letter word. Next, 14th one. Using the digits 5, 6, 7, 8, 9, find the number of 2 digits number that can be formed. So from the numbers, from the digits 5, 6, 7, 8, 9, so totally 5 numbers are given. We have to make 2-digit numbers. So how many ways we can make 2-digit numbers? It is not given, whether it is repeated or not. Information of numbers, although is not specifically given, we must always allow repetition of numbers. Repetition of numbers will be allowed. If repetition is allowed, then number of ways will be n to the power of r, this formula. N to the power of r, if repetition of alphabets are allowed. So here there are 5 digits, 2-digit numbers have to be formed. Total number of permutations are 5 to the power of 2, that is n to the power of r. So 25 ways we can be able to make 2 digits word and a 2 digits combination out of a total of 5 digits. This is 14th problem. Now come to 15th problem. Problem number 15. Find the number of 4-letter words that can be formed using the alphabets forming the word magnify such that they do not contain the letter Y. तो find the number of 4-letter word. हमको 4-letter word बनाना है. कौन से word में से? Magnify. तो find out how many words are there in magnify. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 7 alphabets are there in the word magnify. Now we have to make a word of 4 letters. We have to make 4-letter words out of 7 letters such that they do not contain the letter Y. Y के letter को छोड़ दो बोल रहा हूँ. तो magnify में last Y का letter है. We should not consider Y. It is a saying. It is given in the problem. Don't consider Y. Leaving the Y, out of 6 alphabets, how many ways we can be able to arrange 4-letter word? तो total number of letters are 7. Magnify, ये पूरे word में 7 alphabets है. However, 7th letter should not be used. It is given in the problem. The last Y letter should not be used. तो एक letter को drop कर दो. बचे कितने? 6 letters. Thus, effectively, there are only 6 letters. 4-letter words have to be formed. Thus, it can be done in 6p4 ways. क्योंकि 7 letters से magnify में उसमें Y को consider नहीं करने के लिए कह रहा है. तो Y को छोड़ दो. Leaving the Y, we are having 6 letter. Out of 6 letter, we have to make 4-letter words. So how many ways we can be able to make 4-letter word? So 6p4 NPR. Same formula. So 6p4. It is 6 factorial divided by 6 minus 4, 2 factorial. 360 ways. In 360 ways, we can be able to make 4-letter word, leaving the Y. Next, 16th problem. Find the ways in which 6 boys and 6 girls can be seated such that boys and girls sit alternatively. This is a new point. Find the ways in which 6 boys and 6 girls can be seated. Totally 12 persons are there. 6 boys, 6 girls. Such that the boys and girls sit alternatively. 1 boy, 1 girl, 1 boy, 1 girl. Alternatively, the boys and girls should be seated. So the row may begin with either a boy or a girl. This can be done in 2 ways. तो पहला केस तो ये है कि we can start with a boy, then girl, then boy, then girl. Or we can start with a girl, girl, then boy, then girl, then boy. So 2 different methods are there to make the starting. To make the start, we can start either by a boy or by a girl. This can be done in 2 ways. The 6 boys can be arranged in 6 different ways. And 6 girls can be arranged in 6 factorial ways. अब 6 boys है और 6 girls है. तो 6 boys can be arranged in 6 factorial ways. And 6 girls can be arranged in 6 factorial ways. So total number of ways of arranging 12 persons, 6 boys, 6 girls in a row alternatively, starting either by a boy or by a girl. The number of ways are 2 into 6 factorial into 6 factorial. पहले तो 2 इसलिए ले रहे कि स्टार्टिंग में वी कैन हैव ईदर ए बॉय और ए गर्ल, वी कैन मेक द स्टार्टिंग विद ए बॉय और ए गर्ल, तो 2 different methods are there. Then we have 6 factorial ways in which 6 boys can be seated, arranged. 6 factorial ways in which 6 girls can be arranged. So total number of ways are 2 into 6 factorial into 6 factorial. That comes to 10,36,800 ways. Right? 6 factorial means 6 into 5 into 4 into 3 into 2 into 1. Similarly here also 6 factorial, 6 into 5 into 4, 3, 2, 1. Now 17th problem. Find the number of ways in which 4 boys and 3 girls can be arranged such that row begins with a boy and ends with a girl. Again, very interesting problem. Find the number of ways in which 4 boys and 3 girls can be arranged. Totally 7 persons we have. 4 boys, 3 girls can be arranged such that row begins with a boy and the row ends with a girl in a straight line. एक लाइन में 7 पर्सन्स को हमको अरेंज करना है जिसमें से 4 बॉयज है 3 गर्ल्स है। ऐसा अरेंज करना है कि फर्स्ट में बॉय रहना और लास्ट में गर्ल रहना। फर्स्ट बॉय begins with boy and ends with girl. See, there are total 7 places. The first place has to be a boy and the last place has to be a girl. This can be visualized as follows. You can see here. First we have taken a boy and last we have taken a girl. Total 7 persons are there. Out of 7 persons, first we have taken boy, last we have taken girl. तो 7 में से 2 निकाल दो, बचे हुए कितने? 5 places are there. तो 1, 2, 3, 4, 5. तो in between boy and girl we have 5 places. Thus there are 5 places that can be filled by 5p5 ways. अब ये 5 places को fill करने के लिए कितने ways है? तो 5p5 ways we can be able to arrange this 5 places. The first place of boy can be filled by any boy, that is 4 ways. क्योंकि 4 लड़के हैं, वो 4 लड़के में से कोई भी एक लड़का फर्स्ट प्लेस ले सकता। तो out of 4 boys, any one of the 4 boy can take the first place. तो 4 ways are there, 4 boys are there. Similarly, the last place can be filled by any girl. So 3 girls are there. So any girl can take the last place. So 3 ways are there of taking the last girl. Now, the total number of ways in which arrangement can be done is 4 ways for boys, 3 ways for girls into 5 factorial. 5 factorial, why we have taken? Because 5p5. When we take 5p5, it will be 5 factorial divided by 5 minus 5 factorial. And 5 minus 5 is 0. 0 factorial is 1. तो डिनोमिनेटर अगर 1 रहेगा तो न्यूमरेटर ही बचेगा। न्यूमरेटर में क्या है? 5 फैक्टोरियल है, 5 फैक्टोरियल। तो 4 into 3 into 5 factorial, 1440 ways we can be able to arrange these 4 boys and 3 girls in a row starting with a boy and ends with a girl. So 4 boys can be arranged in 4 ways, 3 girls can be arranged in 3 ways. Remaining 5 in between seats can be arranged in 5p5 ways. And 5p5 ways is nothing but 5 factorial. That's it. Now 18th problem. Find the number of ways of arranging 5 different books of accounts, 5 different books of accounts, 4 different books of statistics and 3 different books of tax. So we have to find out the number of ways we can be able to arrange the books. तो कौन से books है? 5 books of accounts है, 4 books of statistics है and 3 books of tax. Such that books of the same subject are together. सेम सब्जेक्ट के बुक्स एक जगह रहना, यानी पूरे अकाउंट्स के एक जगह रहना, स्टैटिस्टिक्स के एक जगह रहना, टैक्स के एक जगह। तो टोटल नंबर ऑफ बुक्स आर हाउ मेनी? 12. 5 plus 4 plus 3, 12 books are there. Out of 12 books, 5 books are accounts, 4 books are statistics and 3 books are tax. So how many ways we can be able to arrange these 12 books? There are total 12 books consisting of 3 subjects. Accounts, statistics, tax. 3 subjects के 12 books हैं। अब उसमें से since books of the same subject are to be together, we can arrange the 3 subject books in 3 factorial ways. देखिए, all the 3 subjects should be together. यानी पहले 5 accounts के ले लेंगे, फिर 4 stats के लेंगे, 3 tax के लेंगे, या नहीं तो और एक अल्टरनेटिव है, पहले 4 statistics के लेंगे, फिर accounts के 5 लेंगे, फिर लास्ट में टैक्स के 3 लेंगे, या फिर ऐसा भी हो सकता फर्स्ट टैक्स के लेंगे, फिर स्टैटिस्टिक्स के लेंगे, फिर अकाउंट्स के। ऐसा हाउ मेनी वेज वी कैन बी एबल टू टेक 3 फैक्टोरियल वेज, 3 सेट्स आर देयर, तो 3 फैक्टोरियल वेज। ऑल अकाउंट बुक्स कैन बी अरेंज्ड इन 5 फैक्टोरियल वेज। अब देखिए 5 अकाउंट बुक्स है, ये 5 अकाउंट बुक्स को 5 में अगर अरेंज करेंगे तो इट विल बी 5p5, 5p5 वेज। तो 5p5 is nothing but 5 factorial. 5p5 means 5 factorial. So we can arrange 5 account books in 5 factorial ways. Similarly, 4 statistics books can be arranged in 4 factorial ways. 3 tax books can be arranged in 3 factorial ways. Thus, the total number of ways in which books can be arranged such that the books of same subject are together is 3 factorial. 3 factorial means all the 3 subjects should be at one place. All the 3 books of the same subject should be at one place. Then 5 factorial, number of ways in which account books can be arranged. 4 factorial, number of ways in which statistics books can be arranged. 3 factorial, number of ways in which tax books can be arranged. So these are the total number of ways we can be able to arrange all the 12 books such a way that all the books should be at one place. All the subject books should be at one place. Accounts के पूरे एक जगह रहना, statistics के पूरे एक जगह रहना, tax के पूरे एक जगह। तो इतने, in so many ways we can be able to make the arrangement. That's all. So this is the end of problem number 18. Come on students, we'll continue the problems on permutation and combination. So far we have completed 18 problems. Now we'll start the 19th problem. See the 19th problem. Find the number of 5-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5. If each digit can be repeated any number of times. The previous problem we have seen the number of ways in which we can make the combinations of different alphabets or different numbers. Where repeated is allowed, the formula is n to the power of r. N to the power of r. This formula will be applied whenever the objects are repeated. Here it is given repeated. So we have to apply the formula n to the power of r. Find the number of 5-digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5 means 6 digits we are having. But we cannot begin with the number 0. We cannot begin with the number 0. Although there are 6 digits, we cannot start with 0. Thus, the first digit can be filled by only 5 numbers, that is 5 ways. तो पहला नंबर 0 से स्टार्ट नहीं हो सकता, तो 0 को छोड़ दीजिए, 0 को छोड़कर 1, 2, 3, 4, 5. तो 5 different ways. तो we can start the number with any of the 5 ways. Then remaining 4 numbers can be filled up by any number as repetition is allowed. This can be done in n to the power of r ways, that is 6 to the power of 4 ways. So total number of digits are 6. We have to take only 4 digits. So thus the total number of ways in which a 5-digit number can be formed is 5. 5 into 6 to the power of 4 ways. 5 into 6 to the power of 4 ways. So these are the number of ways in which we can arrange 5-digit number from the total number of 6 digits. In the 6th digit, the first digit is 0. So we cannot begin with the word 0. So we can begin with any of the other 5 words, 5 numbers. Other 5 numbers are 1, 2, 3, 4, 5. So we can start with any of the other 5 numbers, that 5. And remaining 6 numbers are there. Out of 6 numbers, we have to select 4 numbers. So 6 to the power of 4 ways. These are the number of ways we can arrange. Now, 20th problem. Find the number of 4-digit numbers less than 2000. Less than 2000 means up to 199. 1999. Below 2000, less than 2000 means 1999. So find the number of 4-digit numbers less than 2000 that can be formed using the digit 1, 2, 3 and 4 if numbers can be repeated. Numbers can be repeated. So whenever numbers can be repeated, we apply the formula n to the power of r. The given numbers are 1, 2, 3 and 4. We need to form a number that are less than 2000. तो जो भी नंबर लेंगे वो less than 2000 होना, 2000 से बड़ा नहीं होना. तो thus the number in thousands place has to be 1. This is unit, 10, 100, 1000. If we expand this 2000, we can say first digit is unit, then tens, then hundreds, then thousands. So this thousands place we are having 2. So we cannot go up to 2000. It is less than 2000. So always the first value should be 1. Thus the number in the thousands place has to be 1. The remaining 3 numbers can be filled by any of the 4 numbers. अब देखिए पहला नंबर ये 2000 जो दिया है, हमको ऐसे 4 डिजिट्स बनाना है जो लेस देन 2000 है. लेस देन 2000 का मतलब थाउजेंड्स प्लेस के ऊपर ओनली 1 ही रहना, थाउजेंड्स प्लेस के ऊपर 2, 3, 4 नहीं आना और थाउजेंड्स प्लेस के ऊपर 0 भी नहीं आना, तो 1. तो रिमेनिंग जो 3 डिजिट्स है, द रिमेनिंग 3 डिजिट्स कैन बी एनी वन ऑफ द 4 डिजिट्स. द 4 डिजिट्स आर 1, 2, 3 and 4. So the remaining 3 numbers can be filled by any of the 4 numbers. This can be done 4 to the power of 3 ways. That is, number of arrangements are 4 to the power of 3 and n to the power of r. N means 4 digits and number of digits we have to take is 3 digits. So n to the power of 4 to the power of 3 ways we can be able to arrange. Now last and final problem on permutation is 21st problem. There are 5 Indians, 4 Chinese and 3 Pakistanis in a round table. In a round table, arrangement has to be made for 5 Indians, 4 Chinese and 3 Pakistanis. Total number of persons are 12. Find the number of ways in which seating arrangements can be made such that all Indians sit together. So we have 5 Indians, 4 Chinese, 3 Pakistanis on a round table. So we have to find out how many ways we can be able to make the arrangement if all Indians sit together. All the 5 Indians should be at one place. At one place. So how many ways we can be able to arrange this? Now see, there are 5 Indians, 4 Chinese, 3 Pakistanis. Let the Indians be taken as one unit as they have to sit together. Conditional problem में ये दिया है कि all the 5 Indians should be at one place. Should not be mixed up. All the 5 should be at one place. So we can treat this Indians group as one unit. Now thus there are 8 elements, 4 Chinese, 3 Pakistanis and 1 Indian group. अब इंडियन में 5 persons है, लेकिन 5 person पूरे एक जगह बैठना है तो एक ग्रुप कर देंगे उसको. तो टोटल नंबर ऑफ elements are 4 plus 3 7, 7 plus 1 8. They can be arranged in a round table as 8 minus 1 factorial 7 factorial. So whenever we have circular permutation, the number of ways are n minus 1 factorial, n minus 1 factorial. Here 8 elements are 8 because 4 Chinese, 3 Pakistani and 1 Indian group. We are treating all 5 Indian as one unit. So 8 minus 1, 7 factorial. The Indians themselves can be seated in 5 factorial ways because 5 Indians are there. So how many ways we can arrange 5 Indians? So NPR. So 5P5. So 5P5 is 5 factorial. 5P5 is 5 factorial. So 5 factorial ways we can arrange the 5 Indians themselves. The total number of permutations are 5 factorial into 7 factorial. The 5 factorial are the number of ways in which Indians themselves can be seen, made the different ways of arrangement of 5 Indians. 5 Indians है, ये 5 Indians को कितने ways में हम arrange कर सकते हैं 5 factorial. उसी तरह जब पूरे 5 को एक unit treat करेंगे, तो how many ways we can be able to arrange 7 factorial. So total number of permutation will be 5 factorial into 7 factorial. This will give you number of ways in which we can make the seating arrangement of all Indian, Pakistani and Chinese in such a way that all Indians will be at one place, sit together. So 5 factorial to 7 factorial. Now what is the second question? Last point. No 2 Pakistanis sit together. No 2 Pakistanis should sit together. Now since Pakistanis should not sit together, let us first arrange the Indians and Chinese on the round table. अब इंडियन चाइनीज कितने हैं? 5 Indians and 4 Chinese. 9 persons are there. So how many ways we can be able to arrange these 9 persons on a round table, circular permutation? N minus 1 factorial. So let us first arrange the Indians and Chinese. Since there are 5 Indians and 4 Chinese, they can be seated in 9 minus 1 8 factorial ways. तो पहले इंडियन और चाइनीज को अरेंज कर लेंगे. तो 9 persons है, 9 minus 1 8 factorial ways we can be able to arrange the Indians and Chinese. If Pakistanis should not be seated together, there are 9 places where they can be seated. जब 3 Pakistanis है, they are not supposed to sit at one place. They can be seated at 9 different places. So this can be done in 9p3 ways. So 3 Pakistanis are there and 9 seats are there where they can be accommodated. So how many ways? 9p3 ways. The 3 Pakistanis can be made sit. Thus the total number of arrangements are 8 factorial. This 8 factorial into 9p3 ways. Now if you expand this 9p3, we can be able to get the total number of ways in which we can make the arrangements so that no Pakistanis should be at one place. That's it. So these are the problems on permutations. So inshallah next video will discuss about the next topic, that is combination. Only few problems will solve on combination.